So we have to change to what again?
You have to change the values into the given unit as as it is there in the option.
So
If the
it's meter per
question,
second. We have to change to meter per second.
yeah, you have to change. First of all, change kilometer into meter, then minute into second, then solve it. Yeah, Sundus.
Like what happened? I got disconnected because my
No
battery
issues,
was
no
running
issues.
low.
Okay, no issues. Okay, we were solving the same question. Okay, now. Chakrika hasn't answered yet, so you also solve it.
So but you already gave it in. Oh, okay, never mind. So never mind.
Okay, okay. We might have practiced the similar question earlier also. Okay, do I need to explain this? Will you guys be able to do it?
So can you just give it?
Sundus, please speak again.
I said, can you just give a minute?
Take your time, no issues.
Yes, but can you give some more time?
Okay, okay, take your time, no issues. Simply know that how do you convert a bigger unit into a smaller unit? For example, in order to convert meter into centimeter, you have to multiply or divide.
Pardon, sir?
In order to convert, for example, in order to convert meter into centimeter, you have to multiply it with
So 100
100. So thereby you are required to convert kilometer into meter.
by
And one, then you have to multiply it with 1000 now,
1,000. Yes, sir, 1,000.
right now. Same thing you can do for second also, but for minute also, you have to convert it into second.
Then I've sent you the answer.
That is correct. Correct.
Okay.
Okay. Also, to tell me, I'm writing some words here, some options here. Example, 5 meter per second, 5 meter per second like this, or 5 meter like this, or let's say, which one is the correct way to write the speed?
So it's the first one.
It's the first
Yes,
one,
sir.
right now? Correct. So that is the right way to write the speed. Sundus, you done with the first question?
Mama, I decided to go school.
Mm-hmm.
So,
Okay. Also, do tell me, Chakrika, one thing. You guys tell me one thing. How do you find the average speed?
and what? An average?
Average speed. Average speed. For
So
example, during a journey, the
distance by total time?
that is total.
Distance by total time? I think so.
Exactly. That is the formula, right now. So, for example, the time taken to cover the journey keeps on changing in a given period of time, right now. So thereby the speed will also be changing, right now. For example, someone is walking a distance of 3 kilometer in 30 minutes. Someone walks a distance of 3 kilometer in just, let's say, 30 minutes, right now. And let's say that for the second time, if the person were to take the same journey, cover the same 3 kilometer distance, now he takes 20 minutes only. So in this case, in the second in the first and the second case, will the speed be same?
No, sir.
No, right now, because he took 30 minutes, but in the second case, to cover the same distance, he is taking 20 minutes. So the speed is not constant. So in the whole journey, we need to find the average speed. So it is simply the total distance upon total time taken. The total distance was covered 6 kilometer. Total time taken was 50 minutes. You have to convert into hours. So thereby you divide it with 60. But we have when you divide it, it will come above. 60 will come above right now. So thereby you're getting 36 upon 5, that is 7.2 kilometer per hour was the average speed of the person. Okay, now. Sundos, what value you are getting for the first question, by the way?
So it's 2 meter per second, right?
No, it's 7.2 kilometer per hour. Which one you are telling me?
Now, which question are we doing? I'm getting confused.
N- No, no, no. This one, now I asked a question regarding average speed. Okay, now. So related to that, I gave a question and then we understood this one. You are required to solve the first question. Shakrika has the answer and that is correct. Let me just tell you the answer. See,
So, before that, I have a doubt.
Let me.
Shakrika, just 1 minute. Okay, now.
Okay, sir.
Yeah. So Sundus, you have to multiply 54 with 1000, right? And 90 with 60 in order to convert it from minute to second. You have to multiply it with 60. This is in a minute. This is in second now. I mean to say, when you multiply it with 60, it will now be in second. So this is 54,000, and this is 5400. So thereby you are left with 10 now. So 10 meter per second is the answer. Getting it now? Option number B. Sundus, you got it now?
Yes, sir.
Hmm. Yeah, Chikrika, you doubt.
So the 3 kilometer, 30 minute that one.
Hmm.
When I solved it, I got um 2 meter per second. So
2 meter per second. This one.
yes, sir.
See, this is 3 kilometer. This is 3 kilometer. 3 plus 3, 6. Okay. So then talking about the time, that is 50 minutes.
50 minutes. Yes, sir.
And you convert, in order to convert minute into hour, you have to divide it with 60, right? So this is like this 60
So basically,
upon
I
50.
multiply with
Basically, you have to,
multiply, right? Like 50 and 60.
uh, no, let's understand the maths behind this. Okay, now it
So
many times students get confused on this. It's 60 upon 50 and 6, sorry, 6 upon 56 is in kilometer and this is in minute. We need to convert it into hours. So thereby you have to divide with 60. Getting it, no? Okay. So this is actually 60
but
divided
if we were
50.
finding it out
Let me erase
according to
the
meter,
other things in it. Just 1 minute. Yeah, Chikrika, will you please repeat that again?
before finding it in meter per second, right?
No, no, you don't have to necessarily find it in meter per second. I didn't say you have to find it in meter per second. This was a question related to average speed. Okay, now. So
So
you
in
can convert it into meter per second also, or you can simply convert the minute into hour and then you will be getting the value in kilometer per hour. Yeah.
so in speed, we have to find it out in meter per second, and in average speed, we can find it in anything like kilometer per hour or meter per second.
Hi, it's up to the question. Okay, now. It depends on the question. And it
Okay.
depends on the given options of the question also. Okay, now. So the formula required to find average speed is total distance upon total time. The total distance was 6 kilometer, total time taken was 50 minutes. So we know that this is distance divided by time, and time has to be converted into minute, into hour. So this thing not same as this? First of all, understand this one. Is 60 divided by 50 upon 60, is this not same as this? First absorb this thing.
So it is same.
So this it is same now, because there's a sign of division here. This is upon. Okay, now.
Sir, but why did you add
No, we are not adding here.
the first thing, 3 kilometer? I didn't
Oh,
get the question.
okay. Let me repeat the question. The question is such that there's a person who is walking from his home to school, and that is 3 kilometer distance, and he takes 30 minutes. All right. Now, upon reaching the school, the student finds out that the school is closed now. So he returns back immediately to his home, and again will be covering the same distance, but this time took only 20 minutes. Suppose he would be he might have taken a rickshaw, or he might have taken a ride. So you need to find what is the average speed. What was the average speed of the boy or the girl here? Getting a Sundus now. So average speed formula is total distance
Yes.
upon total time. So we have added the total distance 6. So 6 also, you know that whenever you can convert this into multiplication, and this will be 60 upon 50. You guys know this. In class 5 or 6, you must have studied this in maths, right?
Yes.
So when we reverse the order of the numerator and denominator, the sign of operation changes to multiplication here. So thereby you will be getting 7.2 kilometer per hour. Hope it is clear now. Okay. Is it clear to both of you?
Yes, sir.
Okay. Let's revise the different concepts then. So first of all, let's understand what do you mean by the state of motion. Starting from you guys, what do you mean by motion? From Sundus. First, Sundus, you answer this to me. And Chakrika, you
A
have to define
movement
what do
like
you
of an
mean when. Sundus, complete. Shakrika, you define to me what do you mean by a rest? When a
Rest.
body is said to be rest.
Should I say it now?
So you can say it now.
Uh, so we know that a body is being at rest when the time is still passing, but the
Huh.
object is on spot, like it did not move or it doesn't
Mhm.
move.
Correct.
That's
Very
Sir,
what
good.
did you
we
said anything to me?
Mhm. And the first one about motion, Sundus, you have to answer that one again.
Motion is like a movement of an object.
Okay. But is that the complete definition? You have to consider time also, right now. So motion is what? If it's the state of it is basically defined as the change in the position of an object with respect to time, right now. So an object is said to be in motion if it changes its position with respect to time. For example, a car moving on a road, and rest when it does not change its position with respect to time. Okay.
So can you come back in like 2 minutes?
Okay, no issues, take your time. Okay. Sundus, you answer this one thing to me, that suppose here on earth we are stationary as respect to earth. For example, right now we are sitting here in the class, so we are not changing our position right now. Several minutes have passed, but we haven't changed our positions since we have been sitting on the chair. Suppose there is a person that is standing on Mars here, and the person sees that the earth is doing revolution around the sun now, right, Sandus? He will observe that the earth has been doing revolution around the sun. Hence, the person that is sitting on this chair is also moving. The person sitting here is not stationary. Hello?
Sir, I'm back.
Yes.
Yeah. So, Chakrika, I was explaining a important concept here. Say this is the earth, this is sun, and let's say this is Mars. So suppose what happened, suppose that I am sitting here on earth. In the class, I am sitting here for the past an hour or so. So with respect to earth, have I changed my position for the last 1 hour? The answer is
Yes.
no.
Mm.
No, with respect to
No.
Earth, with respect to Earth, with
No,
respect
sir.
to Earth, with respect to my room, I haven't changed my position since the last 1 hour. But the fact is that Earth is not stationary. It has been doing revolution around the sun ever since the universe came into existence, ever since the Milky Way galaxy came into existence. Now, suppose there's a person, someone, the Mars, let's say, has been colonized. Okay, and let's say Mars has been colonized. The people are living there, and somehow they can look at us and they will say, no, the person sitting here on this Earth is not at rest. Why is it so? The person, let's say,
Even
let's
the object is moving along with time.
along with Earth, the person on the along with the Earth, the
Um,
person is also moving around the sun. Right now, getting at what I'm trying to say, I'm saying that I am sitting on the Earth. With respect to Earth, I'm stationary. But if a person from Mars looks at me, he will say, no, the person is also not at rest, because he
so
will say that the Earth is doing revolution around the sun. So with respect to the Mars, I am also not stationary. I'm also moving around the sun. Yeah, Chakrika, you were saying something.
so it's so it's about the person.
It says about the person.
Okay, so
Santosh, you got the concept?
Yes, sir.
Okay, no? So also can we conclude that in universe nothing is stationary, because everything is moving, every planet, every celestial body is moving,
Yes, sir.
right? So on a bigger level we understand that the concept that something is at rest, it's not absolute. It change, the definition can change when we consider it in respect of something else, when you compare it with something else. So that's why. But here sitting on Earth, when you compare two things, then you will be able to properly say that one thing is at rest, one thing is not at rest. But when you um, look at two planets and the things on it, then you are able to give a better definition of it. So then you have the distance. So what do you guys understand by distance? It's a simple question. What do you mean by distance? It is nothing but the total path that is covered when someone is moving from one position to another position, right now. Okay, now, so distance is basically a tool using which you can tell how two objects are far away from each other, or how two places are far away from each other, right now. So for example, this is point A, this is point B, or let's say this is your home and this is your school, let's say this is your school, let's say. And suppose the distance between the two, the total length of the path between the two is, let's say, 50 kilometer. So the total path here now, that is being referred to as distance. Now if I were to ask you that what is the shortest pathway between your school and home, is it A or is it B? Let's say this is X or this is Y. Is this X or is this Y?
so it's why.
It's Y,
Yeah.
right now. So distance, we define it as the total path covered by the object in the given period of time. So that is the total distance. See, this curved line is giving you the total pathway, because the pathway between your school and your home is not straight, right? There would be turns in the traffic, in the roadways are not straight. There would be several turns in the path, several turns in the road. Getting it now? So thereby, if we talk about the shortest distance between the two, it will be a straight line, and that straight line is nothing but the displacement. So that is the shortest path which will be covered by the object in the given interval of time. Notice we are talking about time here also. We are talking about time also when we talk about distance here. Right now? Getting it now. Then there will be several units of distances. We did discussed about meters, kilometers, and there is miles is also used for distance. I did told you that in 1 mile how many kilometers are there while we were doing this chapter. So in this, you remember? Shakrika, were you present while we were doing this chapter? I suppose no. Yes, Chakrika?
Sir, I think I joined in the middle or something.
Okay.
Or like I think I've attended. I think done this chapter with the class.
Oh, okay, okay. So answer, you guys answer this to be this question to me. How many kilometers are there in 1 mile? Hmm. Is it 0.6 kilometer? Is it 1.6 kilometer? Which one is the bigger unit?
1.6.
It's the
So 1.6.
1.6.
1.
Okay, no? Mhm. So 1 mile is 1 mile equals to 1.6 kilometer. Getting it? No? So that is the thing here. And the different formulas are as follows. Speed equals to distance upon time. Using the same formula, you can calculate the other things also. Getting it now? Okay. The second formula given here, that is incorrect. Okay, no? Okay, that was a question. I didn't saw that. So out of the given 4 options, which one is the correct here?
Okay.
Obviously the first one. Okay, no? So the rest are incorrect. Okay, I also want you to look at this one thing. Do tell me that if the time increases, if the time taken to cover a journey is increasing, so thereby the speed of the given vehicle is less or more.
So can you repeat?
My question is that if the time taken to cover a certain amount of distance is increasing, right now, suppose they are point A and point B, the distance between the two is let's say 50 kilometer, and suppose you are having a normal bicycle. So in order to cover the distance via the bicycle, let's say it takes 1 hour, let's say 2 hour. Now let's suppose you upgrade to a motorbike. So now you are taking only 1 hour, right now, to cover the same distance. So now what happens? The time, let's say here now we have reduced it. Earlier you were taking 2 hour, now you're taking 1 hour to cover the same distance of 50 kilometer. So will your speed increase or decrease here?
Or
As we
it
Increase.
will increase.
increased, obviously, right now. So can I say that if time increases, speed will time decreases, speed will increase?
Yes, sir.
Time
Yes.
decrease, so speed increase. Or suppose if you were to, let's say now you are you try to walk a marathon of 50 kilometers, suppose, right now. So you might take several hours, you might take 8 hours, for example, or more than that. Getting it now? So then if the time increases, the speed will be decreasing. Getting it now? So can we say that the speed and time are sharing an inverse relation? They are sharing an inverse relation with each other. If one increases, another decreases. If one decreases, another one increases. Can we say this?
Yes.
Chakrika, you got it?
So can you repeat again?
Hmm. I was saying that why this example, as we understood, if suppose someone were to walk a marathon of 50 kilometer, let's say now it is going to take 8 hours, for example. So the speed, obviously, while he or she is walking, the speed will be much reduced, right now. So when you increase the time, so speed will decrease here. And the inverse is also true. If you increase the time, for example, 1 hour is only taken here, so thereby the speed must have
Increased.
increased. So can we say that speed and time are sharing an inverse relation?
Yes, sir.
Getting it now? So
Yes,
yes,
sir.
we can say that. So do remember that thing also. Let me just write it somewhere. Speed is inversely proportional to time. This is the sign of proportionality. You'll understand that in class 8 in mathematics, you will be studying this. Okay, now, so that is the indirect and inverse proportion. There's a chapter. In that chapter, you will be studying about the sign of proportionality. So this shows that if the quantity in the denominator, that is time, increases, another one decreases. If this decreases, another one increases. So that is the inverse relation between the two. Then if you remember, we had different types of motion. Translatory motion was there, periodic or oscillatory motion is there right now. So first of all, let's understand about translatory motion. Okay, now. So translatory motion is what? Suppose there's a ball that is rolling on rolling on a surface. So we say that the ball is also moving forward, and all the parts of the ball are also moving forward. Right now, we say that every part of the ball is also moving further. Ball is moving in further direction, but when you look at every part of the ball, they are also moving in the forward direction along with the ball. You guys getting this thing or not? Let me repeat.
Yes, sir.
When a ball is moving, it is moving forward, right? Suppose you paste something onto it, right now. So after a while, you will see that ball has covered this much direction, this much distance, and the sticker is also there on the ball. It's not like it dropped here. It's not like the sticker on the ball dropped here. Along with the ball, it also moved further. Getting it now? So we say that when the different parts of the object along with the whole object moves in the further direction or moves forward, that is called as a translatory motion. That is called as a translatory motion. The translatory motion is when an object along with all the component, along with all the parts of the object moves forward, right now moves forward, that is called as a translatory motion. So thereby a car moving on a road is also an example of a translatory motion, right now. Getting it now? Earth doing a circular motion around the sun, Earth doing a revolution is also a translatory motion, because all the objects, all the different entities on Earth is also moving around the sun along with the Earth. Getting it, guys?
No, but it's also circular motion, right?
It's circular motion also. So thereby we see now translatory motion. There are two examples of translatory motion. One, that is the rectilinear motion. Rectilinear motion. Another one is a circular motion. Understand these two. Can we observe that rectilinear motion, by the way, do you guys recall this one? We did discuss this. What is a rectilinear motion? You guys define it to me first.
Yes. Sir, a rectangular motion is when an object is moving in a straight path.
Correct. Okay. And circular motions on this?
So what?
What is circular motion? How do we define circular motion?
Um, when it like move in a circular path. Uh,
Right? See, whenever an object is doing a circular motion, right now, so you get to see that, for example, you tie a stone to a thread. You hold the thread in your hand and you roll it like this. Right now, you roll it like this. So your hand is the fixed point around which the stone is rotating, around which the stone is moving. Right now, your hand is the fixed point now. Getting it now? You sit on a Ferris wheel, so you get to see that this is a Ferris wheel, let's suppose, and these are the small compartments into which people are sitting. So we get to see that each and every seats, each and every small compartments into which people are sitting are at the same distance from the center now, around which the whole Ferris wheel has been rotating. It has been moving. Getting it now? So guys, we define circular motion as whenever body moves in the um, whenever the body moves in the shape of a circle about a fixed point. Getting it now? Or can I also say that this fixed distance is nothing but radius? You guys know about radius, right? It's the
Yes.
fixed distance from the center, right? No. So that is what circular motion is there. So also do tell me that every person here, along with the Ferris wheel, is also moving in the circular motion now. Do tell this to me.
Yes, sir.
Okay. Also, the motion of the different planets around the sun, Earth around the sun, you, me, and everything on Earth, along with the Earth, is moving around the sun and doing a circular motion. So these two are said to be types of translatory motion, where an object along with different parts of the objects are moving. Hope it is clear. Okay, no? Hope it is clear. So thereby you had one of the first type, that is the rectilinear motion. So when the body moves in the straight line without changing its direction, then the body is said to possess rectilinear motion. Rectilinear motion has got one more name. We also know it as
Translatory motion.
no, translating. It is a type of translating motion, but we also know it as linear motion. Okay, now it is also known as linear motion since it moves on a straight line. And the third type of motion, we have the periodic motion, in which a body will be repeating its motion at fixed interval of time. So thereby the body is said to be doing a oscillatory motion, or also called as periodic motion. Can you guys give some example apart from the pendulum? What are some other examples of it?
Uh, so the school bell.
Which one?
The school bell.
School bell.
Yes, sir.
Okay. That can also be taken as example. Basically, alarm bell can also be taken. Okay. Now. Do we have other examples? Yes. Yes, on this. Give some other examples of it.
Of
Basically,
rectilinear.
which one? Also, know one more thing, that oscillatory motion is a is one of the type of periodic motion. And oscillatory motion, we only see that happening in the case of those objects which are moving backward and forward direction, in doing a to and fro motion. For example, you release a spring from a height. Suppose you're having a spring and you release it from a height. So
So
thereby you
example
see
of
this. I'm giving an example of oscillatory motion here. Suppose you release a spring from height, it will fall down like this. Right now? So it has contracted and then relaxed and then again got contracted. So like this, it will fall down. Getting it now? Then you have an example of tuning fork also. So for example, look at how a tuning fork will be doing motion. Have you guys used a
uh,
tuning fork? Have you guys seen a tuning fork?
so like we can also say that heartbeat is a Periodic motion.
Exactly. Heartbeat, very good. Heartbeat can also be considered as an example of a periodic motion. So this is what a tuning fork is. All right, now this is the example of the tuning fork. This is the image of it. So when the tuning fork is striked, one of the end is strike, it moves backward and forward. This diagram will give you a better idea. Look at this one. Okay, now. So here you can see as you have striked it now. See the lines here. These lines, they show that they are moving backward and forward. Getting it, Sundu Sanchuklika.
Yes.
So whenever an object moves forward and backward like this, right now, so that is said to be an oscillatory motion. And it will be doing a particular type of forward and backward motion in a given period of time. For example, take the pendulum. So pendulum will also be moving backward and forward and then coming back to its mean position in a given interval of time. So periodic means that it should be repeating its motion. It should be repeating its a particular motion after a fixed interval of time. And there are hmm. and there are several types of periodic motion. One of the type of periodic motion is the oscillatory motion. Another example of periodic motion can be taken as the rotation of Earth and revolution of Earth, because it is repeating its motion after a fixed interval of time. Rotation after every 24 hours and after every 365 and 1/4 of a day, it is
Like
doing a
that,
revolution. Yes,
day and night.
day and night, exactly. That is due to rotation. So that is what we studied in the case of periodic motion. Getting it now? Then also you know that motion will come whenever there is a force. Right now, the cause of the motion is force. Either it can be a push force, either it can be a pull force, right? And whenever motion will come into existence, there will be some amount of friction also developing, right now. So friction chapter is not there in class 7, I think it is in class 8. So there are other causes of motion also. It could be magnetism also, it could be gravity, it could be friction, it could be acceleration also. So these are some of the causes of motion in a given object. You guys tell me, we studied about one oscillation. So you guys tell me, okay, what do you mean by one oscillation?
So one oscillation means when like um so like as in a pendulum or
In a pendulum, for example, let's say.
okay so when one oscillation we say the one oscillation is done when the bob of a pendulum is traveling from its basically starting position um, to
Mean
the
position.
yes sir, to the mean position and to the extreme position and then again the extreme position and then again back to its place.
Correct. Okay, no? Or there is that is one of the way to define one oscillation. Another thing is that also one oscillation is said to when the bob of the pendulum goes from one extreme position to another extreme position and then return back to the original extreme position. Meaning that let's say this bob moves from extreme position B and goes to extreme position C and return back to extreme position B. Thereby also it is said to be doing one oscillation. So you can answer this in two ways. You can say that it goes from mean position A to mean position, starting from this side, let's say. It goes from mean position A to mean position B. and from B it goes to C and then return back to A. That is one of the way to define oscillation. Another way you can see that it simply goes from position B to C and then comes back to position B. Right? You can also understand this in this manner, that if you were to look at this length and this length, you combine them, it becomes this complete length. See, I'm talking about this arc here. See this arc and this arc. Okay, now. So just look at the length of the two arcs here and just look at the length of all these arcs. Are they not same? Yes. Suppose this now covers a distance of, let's say, 2 centimeter going from extreme position B to extreme position C, and it covers 1 and it covers 1. So the total distance covered here is, let's say, 3 centimeter of, 4 centimeters covered here. And here it, in order to go from extreme position B to C, it covers 2 centimeter and again covers 2 centimeters. So that is also 4 centimeter. So via this also we understood that both is true. Whether you say it goes from extreme mean position A to B and then from B to C and then back to A, that is also true. And we can also say that it goes from extreme position B to C and then return back to extreme position B. I hope you guys are getting it.
Yes, sir.
Okay, no? Okay. Now there was another thing, time period. You guys recall about time period? What is time period? What is time period in a context of pendulum?
No, sure.
Yes.
No, sure, sir.
Okay. See, basically time period is the time taken to complete one oscillation. All right, now time period is nothing but the time taken to complete one oscillation. As simple as that. So that is what we study about time period when we talk about the simple pendulum. It is the amount of time taken to complete one oscillation. Right. So for example, a pendulum does 20 oscillations. It does 20 oscillations in 20 seconds. Right. So you need to find what is the time period. So, but we calculate the time period in context of one oscillation also only, right now. So you need to find the time period. So time period is the total number of oscillation upon the total time taken. 20 upon 20, that is the one. So it takes 1 second to do one oscillation. So that is the time period of the pendulum. Let me give you another question. Suppose there is a pendulum that does, let's say, it does 84 oscillation in, let's say, 12 second. Okay, now you guys find the time period of it.
I found it.
It's second time period. You have to find it in second here.
Yes, sir. In second only, right? So should I keep it in the chat box?
You can answer it in the chat box.
But I've sent
Uh,
it.
so what is the question?
The question is that you need to find the time
In
period of
between,
a
sir,
pendulum.
the internet is not working, so I can't hear you.
Okay, no issues. See, you are required to find the time period of a pendulum. Okay, now that does 84 oscillations in 12 seconds.
But I've sent my answer.
You check it out, but the thing is now, the answer given is not correct actually. I will tell you in a minute. Sundus, you also solve this one, then we will understand. Meanwhile, Chakrika, you tell me what is the difference between displacement and distance?
So displacement is when we take a shorter path,
Hmm.
and this distance is when we take the path like basically um, the path we cover.
The total pathway that is covered, that is simply
Distance.
distance. Okay, no? Okay. Sundus, done with this question or not?
Yes, I'm done.
Okay, okay. You're getting no, 7 seconds is not the answer because logically thinking. So, what is the definition for time period? Time period is the amount of time taken to complete one oscillation. So, if 84 oscillations take 12 seconds, if 84 oscillations takes 12 seconds, is it practical that one oscillation will take 7 seconds?
Just can you give me one more minute?
Take your time. Chakrika,
Mm,
you answer this to me. Like, is it
might think
logically thinking? Mhm.
according to its thread and the weight of the bob.
Hmm. No, no, don't count the length of the thread and the weight of the bob. Don't count that right now. Okay, now that is also not relevant to the question. Simply thinking that the time period is simply the time taken to complete one oscillation. So, time taken to complete 84 oscillation is 12 seconds. 84 oscillation takes 12 seconds. So, one oscillation is simply 12 upon 84 now. Yeah. Suppose you can bought 10 candies for let's say 5 rupees. So what is the price of one candy? It is simply 5 upon 10.
0.1.
That is
0.1.
0.5 now, not 0.1. 5 upon 10 is 0.5. 0.5 rupees. That is the price for one candy. Similar to that, you can understand 84 oscillation takes 12 seconds to complete. So one oscillation will take 12 upon 84. 12, that is 1 upon 7. Okay, now you will be getting the value in decimal. You guys getting this thing or not? Please do let me know.
So every time we have to find the time period, we
Well, the
do that.
answer is 1.
The answer is Sundus?
0.1.
How? 0.1 something you will be getting.
I'm
Okay,
just
no?
talking about this
0.1.
nonsense. I was talking about the candy one.
No, no, it is 0.5 now. 5 upon 10 is 0.5 now. For 10
No, no,
candy, the
so
price.
I was talking about the second question, like the first one that you gave.
Okay, okay, 84, this one, no? Huh.
So you
No, the
thought that I was like that.
I thought you were answering this one. No, no, the time period here will be 1 upon 7. All it, and this is 0.13 something you will be getting. 0.13 second. Okay, 0.14 actually. Right now? So just know this one thing
Yes.
that in order to find the time period, many times we confuse this. So logically speaking, and the formula required to find the time period is total time taken upon total number of oscillations done. Do one thing, solve another question. Solve another question. Let's say the number of oscillation done by a pendulum is, let's say, 80, right? Number of oscillation done is 80. So and the time taken to do the oscillation is 40 seconds. So you find the time period of the pendulum. What is the time period of the pendulum? Remember the formula. Time period
The
equals to
decimal
total.
form, right?
Yes.
We convert it into decimal form, right?
You have to convert it into decimal if you are
Okay,
getting a value in fraction.
so found it.
What value you are getting?
So 0.5.
0.5, both of you, right? Correct then. So 0.5 seconds it takes to do one oscillation, right? Again, time period is the time taken to complete one oscillation. Also, you can logically also understand this thing, that it is taking to complete one oscillation, it takes 0.5 seconds right now. And it was doing how many oscillations? 80, right now. So 80 oscillations, meaning that it is 80 multiplied 0.5, that gives you 40. And that in the question is the time that was taken to complete 80 oscillations. Getting the maths or not? Hope it is clear to both of you.
Yes.
Okay, no? So do remember the formula. Time period equals to total time upon total oscillation. Also, hope you guys remember this thing also. In order to convert from kilometer per hour to meter per second, what we were required to do? Simply divide by 3.6. Or in order to convert from meter per second to kilometer per hour, simply multiply by 3.6. Or you can say it simply 18 upon 5 also. Or you divide it by 18 upon 5. Because 3.6 is same as 18 upon 5. Isn't it?
So
Yes.
can you repeat the question including this thing?
See, if you are required to convert the unit of speed from meter per second to kilometer per hour and back from kilometer per hour to meter per second. So kilometer in meter is 1000. 1 hour is changed into minute, that is 60 minutes. And again, the 60 minute is required to change into second. Again, you multiplied it with 60 here. So that is 3600. Upon solving this, you are getting 1 upon 3.6. So basically, you are required to divide 1 kilometer per hour, I mean to say the unit in kilometer per hour, with 3.6 in order to get it into meter per second. Also, 3.6, is it not 36 upon 10? And after solving it, you get 18 upon 5. So that's what I was saying, that in order to convert from kilometer per hour to meter per second, we simply divide by 18 upon 5. And the reverse, you will be simply multiplying with 18 upon 5. Is that clear to both of you?
Yes, sir.
Okay, so in next class, we'll be finishing this chapter. Few basic things are left in the chapter, nothing much. On the basically odometer, speedometer, you guys already know. We'll be studying about graph. We'll be solving some question on uniform and non-uniform motion, and then the chapter will be finished. All right, no? So do revise whatever we discussed in the previous class and in this class also. Okay, so that's it for today.